Hello guys, my name is Rohit and I'm going to be your guide and your partner in learning the industrial electrical engineering. So a lot of you guys might be electrical engineers who are already aware of the concepts, and I'm just going to help you use those concepts in the actual field. I'll tell you an example. The first time I went in a substation, I stood in front of a circuit breaker, an air circuit breaker. I couldn't even recognize that it was an ACB. I had studied everything well. I knew how ACB worked, how arcing happened, how arc quenching happened, how the circuit resonance and all happened. That was totally fine. The theoretical part I had a good grasp on. But there are a few practicalities that need to be understood when you step into an industrial institution. So a lot of things are to be covered, and today I am going to cover power factor and why you need to study power factor very well. It is a very important thing that is going to be very useful if you are going to be a future electrical engineer in some organization, in any organization. I'll say you may be in the grid organization. A lot of companies are there, Power Grid Corporation and the state utilities are there. You might be on the consumer end, you might be in some say consuming plant, in some jute mills, in some cement factories. There will always be a substation, and in the substation the first thing your boss is going to ask you is reduce my electricity bill. That is a very simple funda. Any organization is looking to cut down the cost and be economic. So the first thing that you need to understand that in an electricity bill you will have a column of power factor rebate. If you are keeping your power factor very high, near to the unity, you'll be having a rebate of say around 7 paisa per unit or some other amount. That is what is going to be. So the first question that should come in your mind is, why should I study power factor and whether it is actually useful in the industry? So power factor, what do you understand by the power factor? A lot of guys would say, okay, the power factor is something which when multiplied by the apparent power gives the real power. That is totally true. So a power factor, what is a power factor? A power factor is basically a term which definitely has a physical significance, is a number. Power factor is a number which when multiplied by the apparent power gives you the active power. So in layman's term, if I say if the power factor is high, it will lead to a better active power usage, right? The same current with an improved power factor will give me more active power and lesser reactive power, and whatever the consumptions are there in the field, let it be a heater, let it be a motor, a bulb or anything, it is going to consume active power predominantly. So this will lead to a reduction of current. If your power factor is improved, the current is going to be reduced, right? So the current drawn will be lower and hence the savings will be there. Now the proper knowledge of power factor of a system allows proper planning for reactive power compensation. Suppose you step into an organization which has been following a bad engineering practice, and you identify that, okay, if I go for a power factor compensation system, I will be saving a hell lot of money for the organization, definitely, and that is really appreciable. So for that particular purpose, you need to first study the power factor consumption of that industry or the plant. So to study the power factor consumption, you need to know how to measure the power factor. So let's just start with the most basic one, the basic concept of electrodynamometer type power factor meter. So in an electrodynamometer type power factor meter, what actually happens is we do have a supply voltage right here, right? And we do have a fixed coil which is connected through the supply voltage to the load directly. Okay, so the current I will be flowing through the fixed coil as well as the load. We will be having two moving coils which will be having a spatial arrangement, which will be spatially at an angle of 90 degrees from each other, which you can see here, right? And this definitely is the plane of reference. Okay, fine. So these two coils, these two moving coils, the one coil will be connected to a resistor, a pure resistor. I must say a pure resistor used will be very good, and the other coil will be connected to a pure reactor, and these two coils will basically act as a shunt path for the current, right? The current IA is going to flow in this direction, and the current IB is going to flow in this particular direction. Okay, so this is going to be the shunt path. Now what is going to happen is, as the current IB, so you can see from here is that the IA will be passing through a resistor, and hence it will be in phase to the voltage, and the coil B ideally inductive in nature, and hence the current in the coil, in this particular coil, the current IB is going to lag IA by 90 degree, and the controlling torque is kept minimum by using the silver or gold ligaments for the moving coil. And you will understand why we need to keep the current, the controlling torque to a minimum. We'll understand it later. Fine. Next slide. So let's understand the phasor diagram that I was saying in the previous slide. We are going to understand the phasor diagram. We have the voltage V, right? This particular supply voltage V, and it is marked here. We have the current I, the load current, which is going to flow through the fixed coil. This will be I, right? And this phi will totally depend on the load. The power factor will always depend on the load. So we have this V, this I, this phi, and we will be having the current IA. As I said, it is going through a coil which has a pure resistance. It will be in phase with V, and the current IB, which has a pure inductance, will be 90 degree lagging IA. Now to make sure that the current IA, the magnitude of current IA and the magnitude of current IB are equal, we try to keep omega L is equal to R, because you know the current IA is going to be V divided by R, and the current IB magnitude I am talking about is going to be V divided by omega L. So we are going to try to keep the currents IA and IB equal. Now let's come to the torque equation. The torque equation is going to be TA is equal to kVIm into cos phi into sin theta. Now cos phi will come from here, the cos of this particular angle, the angle between the load current, and the current IA. This is going to be the torque for the coil A. It will depend on cos phi and sin theta, because the sin theta is the spatial angle of this, theta is the spatial angle of the coil A. Now TB is going to be proportional to cos of 90 minus phi and sin of 90 plus phi, because the spatial angle for this particular coil becomes 90 plus phi here, and this particular angle is going to be 90 minus phi, and hence torque for the coil B is going to be this. Now I told you a controlling torque has to be kept to a minimum because it is being ignored here, and for equilibrium we are going to have TA is equal to TB. On solving TA is equal to TB, we get that phi is equal to the theta, or the spatial angle. It means the deflection that is going to happen in these coils, in these particular moving coils, will be equal to the phase angle phi. So this can be later calibrated, and hence the power factor in leading or lagging can be given. Now I hope you people would have understand it, and now since you have understood the basic concept of this electromechanical meter, I will have to ruin something. I have to ruin all your all the studies that has lately happened, I'll have to ruin it now. So nowadays what is happening is, nowadays we are using the solid state devices or the solid state measurement unit. What it will do is, it will take the measurement of current by the use of a CT. It will take the measurement of voltage by the use of a PT, or a auxiliary coil will be there. It will calculate the total power, active power being consumed. Wattmeter, it will consume the total active power being consumed. It will calculate the apparent power as well by multiplying voltage and current. It has the data, right? It has the data for both voltage and current, so it is going to multiply voltage and current to find the active power as well. And internally there will be a microprocessor which will be doing all these calculations, and hence it will divide the total power, apparent power, it is going to divide the active power by the apparent power, and hence you are going to get the power factor. And hence all these learnings is not in vain. You need to understand the basic concepts every time, how earlier, say, elementally the things used to happen, but nowadays the technology has advanced, and now a lot of things are microprocessor based. And the microprocessor, what it does is, it takes the data, it makes calculations, and it internally it has a programming, and it will calculate everything internally, and you will be getting a very accurate result. So nowadays microprocessor based all these measuring units are being used, but still, for an understanding, single phase electrodynamometer has been explained. Thank you, and if you enjoy the video, please like and subscribe. Thank you.